We're now going to have a look at two very important definitions that you need to know. They are relative isotopic mass and relative atomic mass. So I would say probably pause the video now so you have time to jot down these definitions. I'm then going to kind of discuss these definitions in detail and what each part of them mean. Okay, so if we just kind of compare what's the same in both of them, they both refer to something called relative masses, okay? And as you can see, both of these definitions end in the exact same thing. So they're both talking about something relative to 1/12 of the mass of an atom of carbon-12, and the same thing over here, relative to 1/12 of the mass of an atom of carbon-12, okay? So that's where that relative part comes into it. Okay, so I'm just going to cover what that relative part means, and if we just kind of look at the rest of the definition, so the first part for relative isotopic mass is the mass of an isotope. So that essentially just means the mass of a specific isotope. So if you remember, isotopes are atoms of the same element but with a different number of neutrons. Okay, so we're just talking about the mass of the isotopes here. Over here, for relative atomic mass, it says it's the weighted mean mass of an atom of an element. Okay, and we're going to look again in a bit of detail what we mean by the weighted mean mass, and that also comes with a calculation which we will look at. Okay, so let's focus on the underlined bits in red. So what we mean by relative masses and why we keep talking about carbon-12. Okay, so what you need to know in chemistry, when it comes to masses, we have to do, or the masses of atoms or compounds or anything, we do everything relative to an atom of carbon-12. Okay, so carbon-12, which is essentially this over here, okay, this is the standard that we use in chemistry. All masses are done relative to this standard here. Okay, so everything is done relative to carbon-12. And the way that we do that is that we say that carbon-12, which obviously has a mass number of 12, we say that that is equivalent to 12 atomic mass units, which I'm just going to shorten down to AMU. Okay, so it's atomic mass units. So we say one atom of carbon-12 has 12 atomic mass units. Okay, and therefore what we can deduce from that is that one kind of atomic mass unit is 1/12 of an atom of carbon-12. Okay, and therefore that one kind of atomic mass unit is what we equivalent to one proton or one neutron. Okay, so one atomic mass unit is 1/12 of carbon-12, and therefore that is essentially kind of our standard that we use. So everything is done in comparison to carbon-12, and we say one atomic mass unit is 1/12 of carbon-12, and therefore this part here is always referenced in any definition to do with relative masses. Okay, so it's always done, it's always relative to 1/12 of an atom of carbon-12. Okay, so both those definitions are to do with or are relative to 1/12 of an atom of carbon-12. So relative isotopic mass just means the mass of an isotope relative to 1/12 of an atom of carbon-12. If we now have a look in a bit of detail at relative atomic mass, which can be given that symbol there. Relative atomic mass is the masses that you are essentially given in the periodic table. Okay, so if I just show you the periodic table, the relative atomic mass is what is given to you over here. It's the numbers at the bottom, and as you can see, these aren't whole numbers. Okay, so essentially these are calculated taking into account all the kind of isotopes that are naturally present. Okay, so for example, the one that we're going to focus on now is chlorine. Chlorine has an atomic mass, or a relative atomic mass, of 35.5. And obviously we can't have 0.5 of a proton or 0.5 of a neutron. So that shows us that that's done through the kind of, it's worked out using the mean of the isotopes that are present, okay? And that's what we mean by the weighted mean mass, is that you're taking into account all the isotopes and calculating essentially the mean of those, okay? If we want to find out what is the relative atomic mass of something, we have to find out what isotopes are present, and we must therefore take into account the mass of those isotopes, or what we mean by the relative isotopic mass, and we then have to take into account the percentage abundance of each isotope. So how much is there of each isotope, okay? And that's what we then apply to this equation that I'm going to write out, which is to basically calculate the relative atomic mass. So if we have, for example, 2 isotopes present, we will use the percentage of one isotope, and we will multiply that by the relative isotopic mass, okay? And I'm just going to use RIM for relative isotopic mass. And if that's isotope number 1, we do the same thing for isotope number 2, so the percentage of that isotope multiplied by the relative isotopic mass of that isotope, okay? And obviously if there's another one, if there's another isotope, we just do the same thing again, and we divide all of that by 100, and that gives us our relative atomic mass, okay? So we're now going to apply that to a question, and this question is for chlorine, and if we want to find out the percentage and the relative isotopic mass, or the mass of, you know, the atom, all we do is we use a method called mass spectrometry. Okay, and what that does is it gives us the percentage abundance and the relative isotopic mass. Okay, so in this example, as I said, we're doing this for chlorine, and in this question we've been given, after the mass spec is given to us, we're given the percentage abundance of each isotope of chlorine, and in this case there are 2 isotopes present, and one is chlorine 35, and the abundance of that is, the percentage is 75.78%, and for the other one, which is chlorine 37, that has a percentage abundance of 24.22%. Obviously that adds up to 100, so that's accounting for all the isotopes present. Let's now apply that equation that we've just done to this question here. So the relative atomic mass is calculated by the percentage. So I'm going to go for the first one, that's our first isotope. The percentage of that, which is 75.78, multiplied by the relative isotopic mass, which in this case is 35. And that's for isotope number 1. And we add that to the same thing for isotope number 2. So the percentage is 24.22 multiplied by 37, like that, and you divide that by 100. Plugging that carefully into your calculator, you should get a value of, when you plug it in, you get 35.484, so on. And to 1 decimal place, that rounds to 35.5, which is the value you get in the periodic table.